Alright, this is Made Up of Wires. We're back decompiling more Castlevania Symphony of the Night. Probably still going to focus on weapons today. We'll see if we can make any additional progress there. Those have been going pretty fast. I did want to go over some of the things from last week. So if you're not familiar with this Castlevania Symphony of the Night Decomp project, the goals of this project is to take Castlevania Symphony of the Night, decompile the code that was on the original retail CD or UMD or any other way that it was distributed, get back to C code that resembles possibly how the game was originally written, have that C code compile back to the same binary objects that were on the retail releases, and then from there be able to take that C code and modify it in different ways. So there's a bunch of progress that's been made. I'm actually really impressed in the last couple of weeks. I don't know if people are back from summer break or what, but there's been so much activity in these repos on the Discord. So if you want to learn more, there is a GitHub repo, SOTN Decomp, where most of the changes are taking place. There's a Discord that's linked on sotin.z.dev. This has progress of the main PlayStation modules that are being worked on. Sometimes it's hard to see progress here because so much has been done to decompile these stages, many of which are at 100% now. But there's many more stages that haven't even been started. So one of the interesting things that happened over the weekend was weapons. The progress taking a huge nosedive, but that's because some work has been done to change how assets are being extracted from weapons. And this is not actually as bad as it looks. I just looked at the list of weapon functions that need to be decompiled, and it doesn't look any different, so I think it's just a metrics reporting issue. So last week we were working on weapons. This is the change that affected that graph by Xianamo. Really cool stuff. Just part of the project is decompiling. Part of the project is just source management, how things are built, how things can be maintained. And this was really good work to make sure that weapons were portable to other platforms. Some of the things we worked on last week that got pulled in, this is the one from Thursday, the entity weapon attack that we decompiled. And then I think that this was started during the stream and then finished off really just maybe an hour or so after the stream. Entity lock camera, and then there was another entity weapon attack that was decompiled as well that I did off stream. Alright, so I think we're going to go back through and find another weapon function to decompile, kind of do the same thing that we've been doing. If you would like to see some other area, please feel free to comment and I will consider it. Most of the time I don't know what I'm going to be decompiling during the stream. I don't look at it ahead of time. It's a gamble if it's going to work out or not. So far it's been pretty successful because all these methods are pretty similar. Offline I do some of the things that I'm less confident about, that I can sit and kind of stew on for a while. So we're going to start with weapons and then we'll keep going from there. Hi Eldritch. Sorry I didn't say hi last stream. I'm getting used to streaming and juggling multiple things at the same time. I mean, I think any progress being made is nice. The weapons, those are incrementally being finished. Really, I think it's just time, and those will be done, which is really cool to have fully portable weapons, at least in the Weapon 0 module or binary object. All right, so we're going to find, again, we'll just start with the smallest weapon that hasn't been, the smallest weapon function that hasn't been decompiled, and then work up from there. So I have a project. I can go over this. I haven't done this in a stream yet, and it comes up on the Discord when people want to contribute, whether they are programmers, aren't programmers looking to get into code, but setting up the project in general. It's not clone the GitHub repo and hit make and everything goes. There's a bunch of tooling written in Go, Rust, Python, getting the dependencies for all those things set up. To have a working environment is a challenge. One of the things that I've wanted to do for a while and haven't sat down and done it yet is actually get, so you can build on Windows, you can build in Windows subsystem for Linux. I'm working primarily in Linux. I would love to get a build where I can build the original PlayStation objects on Mac OS. For various reasons that are my own issue, some of the dependencies around the GCC C preprocessor, I haven't gotten to install the version that we're using correctly yet. Having a native FreeBSD build as well, same thing there. Not a lot of people building for MIPS or maintaining MIPS ports at the moment, so there's not a lot of external support for things like that. Okay, so we're going to find a weapon. Look in the non-matching. So the tool that's being used to split is Splat64, which was originally written for N64 games, but is applicable to a lot of things. We're going to take the assembly that was extracted there, load it into decomp.me, and primarily work in there for the first part of the stream. I use Find. Most of the tools that I use are just old school Unix tools. That's just the way that I like to work. And I kind of like to tell people what I'm doing because it's kind of an arcane set of tools to use when people are using Visual Studio Code and all kinds of modern things that I don't understand. So I use find assembly files, print the 7th and 11th field from that find output, which is the size and the name of the file, and then I'm going to sort in reverse order to get the smallest one. So then, let's look at that smallest one. So when I open these and look through them just to skim, the first thing that I'm interested in determining is whether or not there's a jump table. The jump tables indicate that there is a switch statement that is larger than something that GCC will turn into effectively the same as a bunch of if-else control flow. Most of these smaller weapon functions don't have jump tables in them. When there are jump tables, the offsets for those tables are stored in RO data, which is a separate file. And so we need to pull that data in as well for decomp.me to decompile it properly. We don't have any of these in these smaller entity weapon attack functions, which is convenient. So I'm going to copy that into a buffer and switch over to decomp.me. So we're choosing a PlayStation project. There's already a preset for Castlevania Symphony of the Night. I'm going to paste the assembly for that function and then see if we can get a good decompile. I haven't recreated my context recently. One of the things that I did that was already in my context here, there was some missing forward declarations for some structs that would print a bunch of warnings. I went through and cleaned up some of that at the end of last week. So anybody generating context should have a cleaner context now, but it also cleans up some of the other builds that we have as well. So we want to clean up and get a built function first. This is pretty standard. This function looks a lot like the one from Thursday of last week. So the first thing I'm going to do, we have a bunch of things about string compare, string copy. I'm going to turn off built-ins. The GCC compiler will provide its own versions of those, but we want to use the PS1 SDK's versions, which for decomp.me doesn't make a difference. We just have different declarations for those than the GCC versions. And then get rid of this standard C hosted macro. All right. Oh, this one does have the struct entity, so we'll go to line 1788 and fix that as well. Most of this is not relevant to anybody who wants to do this, and your context won't have this. So the context is like a header file that the decompiler uses to get context for what types might be. When you're decompiling a lot of methods in the same project, you kind of build up a context that has the structs and the function declarations, and it mostly doesn't change. All right, so these are the same functions that I still don't have in my context. Set sprite bank is a void return with a sprite parts pointer. Set weapons property. I'm going to look up that. We'll copy the signature for that. Oops, missed it. And then this is going to be a sprite part array. And then this likely is the same weapon animation that we saw on Thursday. It falls in about the same place. So right now, there's no, just from the raw decomp, there's no context that I'm using to figure out what these structs are. It's really just experience with these functions. They all follow the same general pattern of how they grab their animation structures. In this case, this the sprite parts here is the same offset for all of the weapons, so it's known what that is. And so all of that can go off into the context. All right. So now looking at the other errors. So we have this one on line 22. It doesn't like that we're doing some math, and then assigning this. So this is going to be array access anyway, and we can change that to be array access. I don't know what the offsets here are yet. We'll go with that and see what the assembly looks like afterwards. 23. So this is an offset. The decompiler didn't know what this was. So it generated a fake field with an offset of C. I'm going to see if the current decomp has figured that out. It hasn't, of course. And of course, I don't remember what any of those things are because I'm old and my memory is bad. So I'm going to pull that weapon animation struct. And keep that as a reference while I'm doing the decompile. So when we see on this weapon animation, when we see an offset of C, that's the same as saying frame start. So we can go through and fix all those. Line 33 is our next. Oh, what do we not like? Incompatible types. Oh. Why is that? I'll come back to see what that warning is about. Oh, our compiler is not caught up to us. All right, this we'll deal with this animation set later. The compiler is warning us that this value is not going to fit in this 16-bit unsigned field. We have too many arguments to set weapon properties. 53. Sometimes the decompiler, let me back up. Sometimes the compiler will stick things into argument registers that aren't actually arguments. It just knows that nothing else is going to be using those registers. Register access is fast, so I'm going to stick some, as the compiler, the compiler, is going to stick some things in those registers to use them temporarily until those are needed for arguments to a function. But nothing is going to stomp on them in the meantime. And so the things we have left then are just these offsets into the weapon animation. So unknown 8 is going to be the palette. Some we can get from the surrounding context. On line 56, we have another unknown C, which is frame start. 57. Unknown D, which is the sound frame. This is very similar to the last one we did. A is the sound ID. 4 is frame props, and 0 is frames. All right, and now are we going to get a compile? No. There's conflicting types for, oh, that's because I have mine here. We'll get rid of that. All right, now we compiled 73%. That's pretty good. Most of these I think start at about 60%. So we have a few additional passes to go through before starting to really look at this. Entity weapon attack functions operate on weapons. This is like a method to a weapon. So we replace the arg0 name with the name self. The name self doesn't conflict with any keywords in C++. This project is in C++, but other code that may be using a C++ compiler may be affected by this, so we use self instead, which is a nice reference to Python, Objective-C, lots of other object-oriented languages that use that as their keyword. We have these player underscore macros. These are known addresses into the first entity. The game keeps a list of active entities. The first one is always the player. These are there for the convenience of the person decompiling, but that's not how they're going to be accessed in code. They're going to be accessed as offsets into a struct. So we're going to change all those to struct access. To find where those are, we'll just get rid of all these. And let the compiler do it for us. All right, so we didn't actually do any work yet, and we're already at 84%. This G player, unknown 46, does the same thing. And then hand ID is a global that's not part of this. The weapon animation is, we'll pull that back in. We'll need that for declaration for when we move this code back. Ah. Sorry, I didn't have any of this up. I was just going through replacing these player global variables with struct access into each of these. All right. So then the next one is GAPI. GAPI is similar. The decompiler knows that we have these addresses mapped to a variable called GAPI underscore function name, but the access to these is also through struct offset. So we'll go through and change those. These will result in differences in the immediate value in the compiled code. So we have to keep in mind that differences in those immediate values are just hard-coded numbers. Differences in those immediate values are due to the decompiler not knowing that GAPI is at a particular address, plus the offset named play SFX. When you combine those two things, will give us the same number as G underscore API underscore play SFX. See if any of those are left. That looks fine. And again, only going through and kind of doing the conventional find and replace relatively mechanical, we have a method that's at 90%. So the tools are really great, and the way the project is set up, and people who came before me have gone through and set up these idioms, make it really easy to decompile. When you look at other platforms, some of the early decompile stuff I did was looking at Genesis, Sega CD, things like that before a lot of these tools were around. You just get a blob of assembly. You don't know what the offset is into a particular function, except for something maybe a Hydra might find for you. And you kind of have to, start from zero, especially in languages or platforms where things weren't programmed in C. This is, it's so nice to be able to get to 90% similarity without really having to spend a lot of time doing it. All right, so we have all that. Our warnings are looking pretty good. The next thing I'm going to do is look for go-tos and other control flow that seems unnatural. The decompiler looks at the assembly, does its best to reproduce the control flow that the compiler might have produced. Depending on the optimization level, compilers can do wacky things with control flow. They might duplicate code, they might remove duplicated code. In this case, GCC decided that destroying an entity and returning was such a complex operation that it should find both instances of that and make sure that those shared code. So here on line 40, that's exactly what we're doing. We're, if this condition holds, we're saying jump to destroy entity and return. Most programmers probably wouldn't write it that way, so we can assume that the original devs probably didn't write it that way anyway. And down here, the other thing is we're returning from this check to avoid doing this destroy entity, but that could be also written just as a else, and we can get rid of that return. And I know from other functions here, we're going to return from there because we're going to be moving some code out of this condition up here. That doesn't change our compilation similarity at all, but it's getting us closer to what the code is going to look like. So we can start going through and seeing where things are different. For example, one of the last things that our compiled code is doing is destroying an entity, whereas the original, that destroy entity comes much earlier. And that's because, as I said earlier, some of the code that was moved into this control flow by the decompiler actually was outside of it originally. So when we move that down, all of this code at the end now lines up pretty perfectly. Again, the only difference between these is the intermediate value. Those intermediate values will get generated differently from what was disassembled by Splat, but when the compiler comes in, it'll say, I have a hex 22 offset into G entities. I'm going to compute whatever that number is, and that address is the same as player underscore rotate pivot Y. The final binary code will be identical. So the next thing I'm going to do, just again kind of as cleanup, is get rid of the casts. Sometimes these casts are necessary. Most of the time the type is correct already, so we don't need them, and they're just noise. Change an increment to the plus operator, to the increment operator. Get rid of superfluous parentheses. And then let's make some nicer names. So here we have weapon animation temp S2. We'll change that to anim for animation. And then this temp v1 here, that's being used to hold the value of frame start, which is being used twice. The compiler will do this automatically, so we'll just get rid of that variable. It doesn't help at all with the final decomp value, but it's unnecessary, so we can get rid of it. Okay, and then temp A2. This is similar. It's just temporarily holding the palette. Oh, we can get rid of that. So in that case, that was replaced, and the compilation is actually further from matching than before I got rid of that variable. And that's because the decompiler knew that this I call this anime, not anime. The decompiler knew that this value was being accessed before flags was being set, and the increment was happening after flags was being set, so it generated the appropriate code. GCC also does this, and it does that by understanding how long different instructions are going to take and kind of optimizing the order that those things are done. And I always forget the order of these, but really it's just changing the order of these fields. Oh, I think it's Z priority that moves. Now I'm going to have to go back and I forget which weapon this is. This is weapon 5. And weapon 5 is the star flail, not one that I'm familiar with. So we've done this in weapon 31. Palette flag Z priority. We'll try that order. All right. So that was the correct order. Those are matching. Now we have a bunch of constants that are wrong. This is similar, where the decompiler will put some of these things in the wrong order. So we just need to figure out what the right order is. So how do we do that, though? That can be tricky. I don't like to focus on immediates right away, but sometimes we do need to look at them and see what's happening. In this case, the assembly is telling us that we're going to load an offset from this register V1. We can go back through and see what was V1. And so sorry, we're loading into V1, we're loading an offset from S1. So what is S1? We have to go back through and find where S1 was set originally. S1 is one of these stack variables that we made, and it's actually the argument that was passed into the function. So when we see A0, that is an argument that's coming in. We're going to take that argument, put it on the stack so that A0 can be reused when it's passed to functions. And that's the calling convention that is used in MIPS. So kind of going back to this. So we have some offset into our self argument. So we can look at what these offsets are. And so for example, we're looking at offset 5A, but our code says offset 16. So we have to go back through and look at what that structure looks like. And so if we look at, they wanted 5A. So 5A is unknown, this unknown 5A field. But we have offset 16. Offset 16 is the palette. So we have a palette assignment in a place where an unknown 5A assignment is, and probably vice versa. So here they have a palette offset, or sorry, they have a unknown 5A offset, and we have a palette assignment. So we're going to switch those two lines. Another hint that that was wrong is looking at the code above. We're going in the order animation set palette unknown 5A. Most of the time, not all the time, but most of the time, if we're changing those values based on some condition, they're going to end up being in the same order. And that got us to 98%. We're still at a little bit of a difference, and so we need to figure out where that is. And looking at the disassembly, the assembly code, we have a shift that we're not doing. And that is going to be here on line 9. The way that params is being accessed, params is a 16-bit value that has different meanings depending on the type of entity that's using it. So we can look at the way that this code gets generated is often not obvious. I'm going to go back and look at how this index was being generated over here. So it was being masked and then shifted. We can try something like that. Sometimes it's easier to go back through and look at similar code and emulate that, see what instructions are generated, and then tweak those values here and there. That's how my approach to a lot of things is just throw something at the wall, see what sticks, and then if that's close enough to what I want, make little changes here and there, and see if if that's going to do what I want it to do. So what this other weapon was doing was taking this value, and this is not anywhere close to what it's doing, so we know that's not correct. So that's okay. We'll try something else. So let's see, they're shifting right. Let's change the value of our shift and see if that makes a difference, and it does. And then they're masking by this 7F value. So we're doing shift right 4 and mask. Look at the decompile. When using 16-bit values to index into arrays, often this is some of these are generated automatically, and that's why I like to look at things that have been done before, because I figured out these problems in the past, and I don't need to spend time doing it again. Okay, so that's not helping. We'll try masking first and then shifting. Eldritch with some nice trivia about the star flail. Thank you. Okay, we're not getting that either. Let's see which ones I did most recently. Because this pattern was in one of these. So this was a shift. It's the one that I took. I don't think that was the same pattern though. Oh, maybe it was. So we'll try that. We'll pull out the index and mask by the max signed 16-bit value and then shift by 8. The weird masking behavior comes from storing it in an 8-bit value, even though we're starting with a 16-bit value and using a 16-bit value to index into the array. And just like that, everything fell into place. Our shift instruction works. Our mask is correct. This is really, I haven't found a good way to mentally model this myself, but in this case, where the mask that gets generated is 7F0 with a 4-bit shift, when what we're doing is masking by the max signed short and shifting by 8. How those things correlate likely has to do with how addressing works on MIPS. I don't know a good way to obviously remember those things, so I rely on when I solve the problem before. Sometimes it's the permuter that helped me find it to begin with. Sometimes it's just banging around on masks and shifts. So what is left? Let's save. So we have this immediate value. That's going to be fine. Another immediate. This immediate value is going to be fine. Immediate. All these are going to be fine, most likely. So we can take the decompiled code, we can go into now the starflail file, and we can paste that in. There's some cleanup that's still going to be necessary. So before we had this include ASM macro, which was including the assembly that we started with into this file in line. When the compiler sees it, it says, hey, it's assembly. I'm just going to leave it the way that it is, and hopefully everything works out, and obviously it does before. So now we've replaced that with C code, and we're hoping for the same thing. We're hoping that everything is going to work out. So we'll build the project. We have an undeclared. This is actually a known value that's generated by the assets tools. It's going to be the animation set. That global is defined elsewhere. Compiled, and everything's okay. So our code that was written in decomp.me matches exactly what was in the original PlayStation 1 binaries. We're not done. We got to go through and make some changes and tweaks to reuse macros and other things that will make this easier for other developers. So this animation set, I'm going to do this in decomp.me because it's easier to get the immediate feedback. This animation set is going to be a overlay specific animation set. So we have a macro for that. That macro basically just ORs the value OX 8000, hex 8000 with whatever you pass it, and that is going to give us the same value. The palette, I don't think the palette numbers matter. The flags is the next one. So we're looking for a flag that is equivalent to 40,000, hex 40,000. Not player status. And that is an unknown. That's going to be masked with unknown 20,000. Likewise, draw mode. There are macros for that. We're looking for draw mode 20 and 40. No. 20 and 10. So that is T-page 2 and T-page. Most of these sound effects now have values. So that is the door open. No, that can't be. Door open sound effect? No, sword B. That makes more sense. All right, thank you for the G entities comment. Yes. So this is an interesting one as well. I'm not sure why the decompiler didn't pick up that this was player when it did for the Y value. So a little bit about how arrays and pointers and things like that work in C. An array looks and acts a lot like a pointer, and you can access it like a pointer. But the value of the array is the address that the array starts at. So in this case, gEntity is an array. It also can be used as a pointer to the first element in that array, which is what the decompiler decided to choose to do with it. This would be the same as saying gEntity's pointer is the same as gEntity's 0, and then using struct access operator to get to those fields. But gEntity 0 is the player. Thanks for that. And we haven't changed how close we are. Oh, I don't have this. I don't have my decomp.me window open. Apologies. All right, so to kind of back up for the last set of changes, the animation set was originally negative hex 7F0. That was changed to a macro for hex 10 or 16. The draw mode was changed to 2 macros, ORing those together to get value hex 60, no, hex 30. Flags was set to 2 macros to get value hex 60,000. And the compilation percentage didn't change as we were doing those things. Again, I used decomp.me to do those because then I can get the real-time hex difference and see if I screwed this up and instead of 4,000 I did 40,000, it's going to compile and now I get a big difference. I don't get that through make. I'll just get that the final compiled value is different, which isn't very helpful. All right. Yes, the set sprite bake can be changed here as well. And likewise, that will change the immediate value when this, actually, oh, I don't have a forward declaration for it. We can change that and get that in there. Actually, we'll just change the one that exists already to animation set. And so when that compiles, as was mentioned, we get the immediate value difference. They're going to compile to the same thing. We know that decomp.me doesn't have enough context to know that. But it does mean that when or if somebody comes back through and looks at this scratch, that they will see the right values here, which is helpful for other people who are decompiling. I like to mark these as overridden matches as well for the same thing, for the same reason. And of course, it's nice to get the party emote because we finished. So we'll go back through in our editor, make sure that that is okay, and it still is. So we start with this file that was importing assembly, went through the process of disassembling, and got to a working function. And now we're going to go through the rest of the software process. I'm going to compare this to, I think, weapon 33, just to make sure that I don't, I'm not missing any of the other macros. Palette. So palette, we're going to wrap in a macro that says this palette comes from the DRA program, which is the main overlay for the game. And if you look at these functions side by side, these are nearly identical. So identical, in fact, I'll copy this line so that these are ordered the same. Oh, there's a few more things. We're going to go back to decomp.me. So player has this ext field, which is a blob that's used by different entities to store value that's specific to those entities. This is the player, so we can use the player extension, and I think that this is anim, yeah. And again, we want to make sure that those values stay the same, that we're not getting any further for our decompilation than we were before. This extension stub, so this is the same thing down here. It's going to be ext player anim. And this is offset 30. The self is going to be a weapon entity. So instead of just using a stub of bytes, we'll use the weapon, and that is the animation index for the weapon, I believe. Spelling. So the way the ext field works, it's a union with several different structs for all of the different entity types. And so after ext, we choose the weapon type that we're interested in. They all overlap the same address as a memory. So that stub offset 30 versus accessing the union name weapon.anim, those are going to be the same offset. All right, anything else in here? I think that looks okay. So we'll take that one again. Make sure we didn't mess anything up. Everything looks good still. Okay. So now we want to get this back into the decomp project so that other people can leverage this work. So we're going to create a new branch in Git. This was weapon 5, and this was entity weapon attack. Make sure that our change is what we expect, which is just replacing this function. Write a nice comment. And before we submit this for a PR, we have our local commit and can always get back to that. We're going to run make format to go through and make sure that the code is meeting the conventions of the project. And look at that. Did it really not? Typically, I like to put things on new lines when Clang format wouldn't, so I'm a little surprised that it didn't change anything. These lines would be too long and would need to be broken up anyway. And it looks like I didn't didn't break anything else. So, okay. So I'm going to upload that to my fork on GitHub. When I go back to GitHub, and it'll say, hey, you just pushed something 8 seconds ago. I do another review once it's up in GitHub. Again, just kind of checking the things that I know that reviewers will find and that I typically screw up on. I don't see anything too egregious. One thing I do want to do before we go further is see if this entity weapon attack was identified as a duplicate, because it is so similar. So one of the tools that's used in this project, we believe that a lot of the code was either copied or common files were used so that compilation units were built in to different stages and weapons and things like that. There are some cases, though, where code is nearly identical, but maybe a value is different. So there's a tool that goes through and compares all the assembly to see if there is similarities. And coincidentally, this is not picked up as a duplicate. There are lots of entity weapon attack functions that are duplicates. And this looked almost identical to 33, I thought. But the tool didn't find it. Just for fun, let's see how similar they are. Oh, it looks like I made that mistake with G entities in 33. So the mask is different. Oh, because of casing. The diff tool ignores addresses. So there's this condition, additional condition, where unknown 46 needs to be set to something. And that must change it enough. Draw mode is set in one and not the other. And then there's another condition down here that's not duplicated. So there's a threshold for the duplicate finder, and this must just be right on the edge of that threshold, because this is so similar. Many of these weapon functions are just variations on one another. I did make some changes, and so let's make sure that those are still working. So when I rebuilt, I got a failure in the Dracula object, which isn't the one that we're editing, that's due to some dependencies that are missing in the make file. It sees that nothing in the dependency graph of that dra.bin file was modified, so it's safe to do the check early, but something had, and it was in the middle of being modified. I'm going to submit these changes for weapon 33 since that's a small enough change. And I'll note it in the commit. If there's anything that people want to see next, feel free to post in chat. Since this one is almost done. All right, so I don't see anything else egregiously wrong. So I'm going to create a pull request. This will kick off a bunch of automated checks to make sure that I did actually run the linter, which I didn't do after I made those changes. Drat. When I changed that to accessing the player anim field, that made the line short enough that the linter pulled it onto the same line. So those verification checks are going to fail because it's not going to pass the linter. But it looks like it already picked up that change. So those checks are going to run. The Discord, there's a notification that gets pushed there. Sozu and Ziynamo and Biz Murphy and a lot of other people who are contributors to the project will come through eventually, and they will do a review on these changes. And if they meet the standards of the project, they'll be merged in, and everybody else will get to benefit from this work. The other things that I have been working on in most of the time off stream, I'm not working on weapons. Those are easy things to do on stream, which kind of highlight a bunch of the low-hanging fruit that other people might be able to come in and work on as well. Some of the more challenging things, at least things that I find challenging, are related to how stages and other objects are configured in Splat so that we can have logical compilation units. So basically one C file, which turns into one .o file, which then gets built into the final .bin. How can we split those up in ways where code that is shared between a bunch of stages, for example, can be reused in those? So I've been looking at NO3. NO3 is one of the stages that is still outstanding, that has the most work left to be done on it. A lot of the code is duplicate code. Some of it's not. But there are some of the problem isn't necessarily with decompiling, it's with getting the layout of that directory and those code files into a state that some of the code that has already been decompiled can be shared. Because there are things like global offsets, function offsets, and things like that that, unless they have been mapped and given names, don't easily translate. One of the things that has been going on in the past couple of weeks that's been hugely useful is trying to find where data is, RO data, BSS data. Those are 3 different segments of the final compiled binary, where all that data is, pulling all of it into the C file, and then marking it all as static so that it all gets built at the same time, but also that the names of those particular variables don't make a difference in the overall in that overall stage. And once that happens, then you just need to know the offsets of each of those sections, and you can easily map in that shared code. So I was looking at bone scimitar in NO3, and was able to look at, I'll open that up. The NZO stage. To get what the sizes of these offsets were, and start laying out NO3 in a similar way. For some of the enemy entities, these don't appear in all of the stages, but once these are mapped, and once it's all code and assets that are producing these, then modders can come in and they can say, I don't want a bone scimitar here. I want spittlebone, or a warg, or something like that. And I think that's when modding is going to become fun, and people will be able to go through and really start hacking on randomizers and other things like that, where you can kind of have arbitrary enemies in a place. One of the things that I'd like to see, and many others as well who are working on the project, is how close could we get to something like a Mario Maker with Symphony of the Night? That would be incredible. Eldritch, who's in the chat, he works on the randomizer. Some of the stuff that the randomizer does is really just astounding and amazing. And I think it's going to be really awesome when even more things can be modified. So what I was doing here, Bone Scimitar in NO3 was just off in one of these offset C files. So we have Splat comes through and we'll say, hey, I think a function starts here, or I think some data starts here, and give kind of a rough idea of where the offsets are in a file. And then people come through and decide these are all functions related to, in this case, bone scimitar. They should all be in their own C file. And oh, by the way, every time bone scimitar is used in any level, it always contains this data, it always contains these functions. And so if we can just include this one C file and you get a bone scimitar in your level, that means one, we can have that in any level, but also every time that appears now elsewhere, we don't have to rewrite or decompile this code. We can just reuse what's there. But somebody initially has to go through and make sure that that particular set of that file and that data is portable to being included in different levels. Just catching up on chat. All wargs, yes. So Eldritch mentioned that there's different address to determine drops. Are you referring to the offset based on how it's built into that level, or is there a different behavior that's also? So that that may be related to how the different stages are laid out. Let me see if I can. So I was looking at this yesterday as well. Let's go to the data. Here we have a, oh, I'm looking at the same level. Okay. So I haven't gotten to the point where I have gone through that disassembly yet. Let's look at the file. I was hoping that I could just pull that in, but oh, interesting. So Eldridge is saying that in the different stages, the bone scimitar behavior is slightly different. So this one hasn't been, the main entity function for that bone scimitar has not been decompiled yet. I was hoping that once I got the offsets in place for some of the globals, that it would just fall into place, but now it looks like maybe that is going to be different. So in the NO3 stage, we still have this include ASM for the main bone scimitar. NZO has this decompiled. Looking at this bone scimitar parts, which likely is the same, the major difference between the two stages for something like this is going to be the offsets. These are variables that are automatically created by Splat based on the address of this global field. We try to go through and when these are common, take them and give them a name that can be reused across stages. So in NZO, this was given the name animation bone rot. So to go through the process of what that would look like here, I can copy this address, go into the symbol table for NO3. Oops, how did I'm going to have to go through and find the for declaration for that as well. Make sure that I got the right name here. And now when if I would run Splat right now, that automatic variable D underscore 8018388 will now be known as NM bone rot. I'm going to look for that and see where the for declaration is. Now because I changed a symbol name, I'm going to have to run Splat again, and Splat will I guess I probably wouldn't have to run Splat. I would have to make sure that any file that referenced that, actually I'll have to run Splat again because this branch has a different config anyway. Normally, I don't think I would have to. As long as that C file changes, the linker will look at that symbol table and point to the right symbol. Something broke. Okay. We're using that multiple places. Oh, I didn't update the reference where it's being used. This was called Either my splat config in this is broken or something else is broken. Odd. For reasons that are going to require some investigation. The bone scimitar assembly isn't being extracted correctly at the moment. This is in progress. It would be nice to be able to get to basically combine as much of this code as possible. And there's a few other things in NO3 that are similar. Looking at the duplicate list. Bone scimitar was the big one. I thought there were others as well. Anyway, that is what I'm going to be probably spending some time on. In a bit. Looking at some of the review comments. I'll fix those up as well off stream. So if you're interested in decompiling, if you're interested in Symphony and Night, the Long Library Discord is a great place for people who are working on current mods, randomizers, things like that, speedrunning. The SOTN Decomp Discord is a place where people are chatting about how we're going about decompiling Symphony of the Night. SOTN.z.dev has lots of information. SOTN-Decomp on GitHub is where you can find the code for the project. And that's it. I'll be back tomorrow with another decomp. Later.